Hi guys, welcome to today's lesson. So today guys, we're going to do some interesting stuff which I know that this is one thing that you guys understand and you are able to then get some answers on it, and I promise you, if you can master this, then clearly you then have some marks that you can then just pocket as soon as you get to paper one, because this is mainly about paper one, right? But the topic that we are doing is evaluating series, and this is under what we call number patterns. So let's just look at a roadmap of what exactly are we going to try and look at in this particular session. So we're going to look at what we call number patterns. As I just said, it's divided into two. It's a sequence and a series. I will explain what a sequence is about, and then under a series we have what we call an arithmetic series, a geometric series, some sigma notation there. With the geometric series, at times it is a converging one, at times it's a diverging one, and then also lastly it will be sum to infinite. That means me finding the sum of an infinite number of terms. But before, do you know what is the difference between a sequence and a series? Because really, if you do not understand this difference, I promise you, it's going to be a problem for you to understand what you need to do. But this is the leading question for this session. Also, is there a formula that you can use to then calculate the sum of a given sequence? If maybe I give you 1 plus 2 plus 3, what is the sum? You know, 6. But what then if I then give you a sequence and I say it's for 100 terms? Are you going to write all of them until you get to the 100th term and then add them? I don't think so. So that's why we then going to also focus on some formula to then do this. Now our keywords will be a sequence. Remember I said that, a series, what we call a common difference, and also a common ratio. Remember, difference is about subtraction, ratio is about multiplication and division, right? So difference is about plus and minus, by the way, because at times a difference between two negative numbers will normally be a positive number. And then now a sequence will be an ordered list of numbers or terms. Under number patterns, we're not really going to call them numbers. Instead, we are going to call them terms, right? Because I'm going to say term 1, term 2. You will see we use T as I've shown you here, right? It's T1, T2, T3. You continue T4 like that consecutively, by the way. You can't then say T3 and then the following one you say T7. Really, that wouldn't make sense. Hence we said it's an ordered list. Also, an arithmetic sequence, which is one type of a sequence, is when a sequence where the difference between consecutive terms remains constant. So the difference between T1 and T2 will be the same as the difference between the T2 and the T3, which will be the same as the difference between the T3 and the T4. That's what consecutive means. Not T2 and T4. No, it must be one after the other. Now, in an arithmetic sequence, we need to get some vocab out of the way. The A, we call it the first term. You will see I'm going to be using A a lot, which is T1. Also, we use the letter D, which means common difference. Remember, that's why I said the difference between consecutive terms is equal. And then also we have N, which represents the number of terms. Now, a series will be the sum of an ordered list of numbers or terms, right? Series is just you adding the sequence, right? So I had T1, T2, T3 continuous. As soon as I start adding them, we then call it a series. Now, an arithmetic series, because we're still talking about an arithmetic sequence, the arithmetic series will be when adding the terms of an arithmetic sequence, right? So we do have a formula to then calculate the sum of an arithmetic sequence, right? Which is the arithmetic series. When we know what the number of terms, we then use the formula Sn is equals to n over 2 into 2a plus n minus 1 multiplied by d. Obviously, you are not going to write it as Sn because you will then know what the n is, which can be 100, can be 500, can be 1,000, depending on how many terms they want you to find the sum of. But also, there will be a time where they just give you the series and they give you the last term. To then find the sum of that particular term, of that particular sequence, or series, you will then use Sn is equals to n over 2 into a plus last term, which is normally represented by L, right? Now, we have what we call sigma notation. Sigma notation, remember guys, we are mathematicians. As much as we are the smartest people, we are actually the laziest people. So we take these long things and we write them in a very short, concise way. And one way of writing a long sum in a concise way, we call it a sigma notation, right? And it is represented by a Greek letter which looks like a very funny E, right? Now, with the sigma notation, the top part normally is the number of terms, but I want you to then not always take it as what is there is the actual number of terms, right? It just tells you how many positions you have. And then the TK here will actually be the general term of that arithmetic series or arithmetic sequence at the time. And this represents the sum of the n terms. K is equals to 1 normally talks about the position of the first term. If I say K is equals to 2, I'm saying the position of the first term is actually at number 2, not at number 1, you see. So that's what it means. Now, Sn, as I said, will be the sum of the n terms. How do I find the n terms? It will be n is equals to the top number minus whatever that K is at the bottom plus 1. Let's make an example with this. The first position or the first term is at position number 1, agreed? And there's 12 at the top there. It means that position number 1, number 2, number 3, until you get to 12, there will be 12 terms. How do you get that? It's 12 minus 1 plus 1, which will just be 12. But as soon as I change it at the bottom, then it's a different story. But I will show you when we do an example exactly what I mean. Now, let's calculate the sum of the arithmetic series, right? It's 3 plus 7 plus 11, up until 30 terms. So firstly, I will say my A value will then be the 3 there. My D value, which is the difference, is the 7 minus 3, which is actually 4, which is the same as 11 minus 7, right? And then I start, my N value will then be the 30. I go to my formula. As N, you first start with the formula so that you know what you are going to substitute where. 2A plus N minus 1 multiplied by D. Our N, as I said, was 30, right? So let me just fix my equal sign there. My N is 30 over 2 into my A is 3 plus, and then my N there is 30 again, minus 1, and my difference is 4. Then you can just press your calculator, guys. You don't need to then try to do some mental math or anything of that sort, right? So this is going to be 30 divided by 2. You open the 2 brackets, but let me just open 1 because 2 times 3 is just 6. 6 plus, and then the 30 minus 1, which is 29. And then you multiply this by the number 4. And close the main bracket. This will give you an error there, so I must just put a multiply there, sorry there. It becomes 1,830. So the sum here will be 1830. Then you're done. But now, what did I say? Here it's Sn, right? As soon as you then know what n is, you must then say it's S30, meaning the sum of the first 30 terms. Now the second question is, now I know what the last term is. You can see they did not say up to how many terms, it's just the last term. So this will be a is equals to minus 1. The value of d will be minus 3 over 2 minus 1, which is the same as minus 3 over 2 plus 1. Therefore, this is minus 3 plus 2, which is actually minus 1 over 2. That will be my difference. And then my n value, I will first need to find what the n value is, right? Using the Tn formula. Tn is equals to a plus n minus 1d. The last term is minus 16 equal to, I need what the a value is, I know, minus 1, plus, I'm trying to solve for n. And this will be minus 1 over 2, right? So I'm just going to go to the calculator and do everything on the calculator. So firstly, it will be minus 16 plus the 1. I find what my answer is. I will divide this by negative, let me open brackets, by negative 0.5. And this will give me 30, and then I will add 1, which will give me, you can do it step by step. I'm just doing it so that I don't have to then do a lot of work, right? So it's n is equals to 31. Then automatically you can see that now I know the formula Sn is equals to n over 2 into a plus my last term, right? The n value is 31 over 2, so remember, it's S31 into multiplied by the a value there will then be minus 1, and then plus my last term is minus 16. Then you press your calculator, guys. Remember, please don't worry yourself about doing mental maths here. So if I press my calculator, I will divide this by 2. I find my answer. You multiply it by, inside the bracket, it will be minus 1 minus 16. And my answer will be negative 263.5. Negative 263.5. And then you'll be done, right? Let's look at some sigma notation quickly. Now I said k is equals to 2. So it means the n value here is actually 23 minus 2 plus 1, which is not equal to 23. So 23 minus 2 will be 21, plus the 1 will be 22. What does that mean? It means position number 1, we don't look at it. We only start at position number 2. That's where my first term is going to be. And because this is an arithmetic series, you then know already that the value of d is actually 2 there. And then you can go straight to your formula, which is n over 2 into 2a plus n minus 1 multiplied by d. But for this to be easier for you, you just need to then list the first 3 terms, right? So term number 1 will be 2 times 2 minus 3, which is 4 minus 3. That's term number 1, right? Because the first position is at number 2. And then it will be 2 times 3, which is 6 minus 3. And then it will be term number 3, which is 2 times 4, which is 8 minus 3, so 8 minus 3, you see. And then you can then simplify it from there. This is 1, this is 3, and this will be 5. So you can see my difference is 2. You substitute it there, you get your answer. Let me show you. Remember I said the number of terms is 22, so it's 22 over 2. And I'm going to multiply this by 2 times 1 is the same as 2 plus 22 minus 1 is 21, that is, multiplied by the value of d we said was 2. Close your bracket, your answer is 484. So this is actually 484. And then you can do that step by step using your calculator. But that's really what sigma notation is about. So far, make sure you write down your data. What is A, what is D, what is the number of terms, and choose between the formula that uses the whole formula with the A and the D and the N, or the formula with just the a and the last term, provided you know what you are given, right? Guys, I hope that is very clear for you. But for now, let's just take a quick ad break. Drink some water, come back refreshed, and I'll be back with some more maths. Hi guys, welcome back. So we are still looking at evaluating series, right? Or which is actually under number patterns. We looked at what a sequence is and what a series is, but only under the concept of arithmetic, right? Which has to do with addition and subtraction. Now let's look at when it has to do with multiplication and division, which we then going to call a geometric sequence and a geometric series. So for now, let's look at what is a geometric sequence. So with a geometric sequence, it will then be where the ratio between consecutive terms remains constant. So the ratio is normally given by a small letter r, which is the same as you saying T2 divided by T1, which must be equal to T3 divided by T2, which must be equals to T4 divided by T3 continuously so. You see, as long as it's consecutive terms, then you will get it correct. Now, we have a series as well under the concept of a geometric sequence. This will be the sum of an ordered list of numbers. Remember, we spoke about that. With a geometric series will then be when we are adding the terms of a geometric sequence. Now, with a geometric series, we also have a formula to calculate this. And the formula to calculate this will be normally when you know the number of terms. With this one, then it's only when we know the number of terms, really, which will then be Sn is equals to a into r to the exponent of n minus 1 over r minus 1. But r must never be equal to 1, because you know that will mean that the denominator will be 0. Now, just on this, I want to make a point here. I know that there are two formulas on the formula sheet that have to do with this, right? And people normally ask me which one to use between the two. Honestly, either one of them is correct. Don't look at this thing of if r is between that and that. No, both of them will be correct as long as you pay attention to the signs, because at times the other formula will give you a denominator which is a negative. Some people don't really know how to work with the negative denominator. That's why they choose which one between the two. Or the other one will give you a denominator that is a fraction. Some people don't know how to work with that. But remember, you have a calculator, and this I will never say to you without the use of a calculator. So either or, it will still give you the same answer. Just make sure that you pay attention to your signs, right? So now we also have some questions that you can do here. It says calculate the sum of the geometric series. The sum of the geometric series up to how many terms? 10 of them, right? So I said to you the formula will be Sn is equals to a into r to the n minus 1 all over r minus 1. You don't then need to say r must not be equal to 1. I'm just telling you that if I give you, excuse me, if I give you a sequence or a series and then you find r as 1, then you cannot do anything that has to do with a sum, please. Right? That's what I'm just trying to tell you, that my restriction will always be that. So r must either be greater than 1 or less than 1, but not equal to 1. So here my r will be the 6 divided by 2, which will give me 3, and it will be the 18 divided by 6, which will also be 3. So that's my common ratio. The number of terms will be the 10 that I have there, and then the value of a will be equals to the 2 there. Then I substitute, right? So this will be my a value, as I said, is 2, open the bracket, my r is 3, not squared, and I'm already thinking about squared here. The n will be the number of terms, right, which is 10, then minus 1 over 3 minus 1. And you can then go straight to your calculator, guys. And on the calculator, if you want to solve this, it will be 2, open the bracket, 3 to the exponent of 10 minus 1. You just put it as is, right? 3 minus 1 is just 2. I can just leave it like that, which is 59,048. So this is 59,048 or 84. Let me just, yes, 48. So this is 48. Now, what you then also need to look at is the concept of a sigma notation that has to do with this one, right? Remember we said sigma notation is about the sum of n terms, right? Even with this one, for you to find n, you still apply the same rule. So my n value will still be 12 minus the 3 plus a constant, which is 1. 12 minus 3, last time I checked, it's supposed to be 9, unless you're now using a calculator that does not look like mine, plus 1, it will then give me 10 there. I'm just kidding, guys. And then from there, the value of a, you will need to expand this thing, right? But the first term is at 3. So this is 2 to the exponent of 3 minus 1. The second term will be 2 to the exponent of 4 minus 1. The third term will be 2 to the exponent of 5 minus 1, like that, right? So it means 3 minus 1 is 2. This will give me 4. 4 minus 1 will be 3. This will give me 8. 5 minus 1 is 4. This will give me 16. So if I divide here, I will have then 2. If I divide there, I will have 2, right? So I go straight to my formula. So remember, the formula is Sn is equal to a r to the exponent of n minus 1 over r minus 1. Then let's go back and just make sure that we know what our terms are. The n is 10, the a value is the 4, and then the r value is 2. So this is 4, open the bracket, that is 2 to the exponent of 10 minus 1, close the bracket, all over my r value there is 2 minus 1. Then you go straight to your formula, right? Or your calculator, I mean. So it's 4, open the bracket, 2 to the exponent of 10, and then you subtract the 1, minus 1, close the bracket, over 2 minus 1 is just 1. Then you find what your answer, which is 4,092. So this will be 4,092, and that will be the answer there. So let me just give you a few steps that I think are very important for you to do both the things that we did in the first segment and in this segment. When dealing with the sigma notation, right? When dealing with sigma notation, these are just pointers that you need to try and look at whenever you are doing this. Number 1, make sure that you expand, right? Meaning when I say expand, you find the first 3 terms, right? That's what you do. We are just summarizing the concept of sigma notation because I know that it's a bit of a problem for you to do this one. Then number 2, you find n, right? Find n. Remember with n, it is actually given by the top minus the bottom plus 1. It's a general formula, right? You find n using that formula. Number 3, you decide which sequence it is that you are dealing with, right? Normally when the variable is an exponent, you already know it's a geometric. So I will just say use I will call it just AB, which means appropriate sum formula, right? Make sure that you use the appropriate sum formula, and then you will be done from that. Please press your calculator, guys, when you're doing this. I know at times we try by all means to do mental maths, but here it is not necessary for you to do that. You can just press your calculator and everything will go right for you. Now, the other thing will be when they say to you then write the series in sigma notation. That's another thing. Writing the series in sigma notation, then you actually don't follow these steps that I have here. Instead of you expanding, it will already be expanded for you. You then definitely need to know what the number of terms, right? But instead of expanding, your first step will be to find Tn, right? Which is the value of what is the general term. So if you look at all the questions I've given you, this here represents Tn of a geometric series. So you need to make sure that that's the first thing that you find. And then from there, step number 2 is the same as what is up there. You find the number of terms, and then lastly, you express it as sigma notation. And then you'll be fine. Your n value is there. With you guys, when they want you to find it as a sigma notation, your k value here is always equal to 1. You don't play around with, let me jump and make it 2. Because if I say you have a freedom there, then I will be having 20 of you in one class. One will have k is equals to 1. The other one will have k is equals to 5. The other one will want to be creative and then say k is equals to 10. So all of us, if we are writing something in sigma notation, we always use k is equals to 1. And then that will make it easier for us. So guys, I hope that clarifies a few things here that you need to look at, please. Remember, sigma notation is how we shorten writing a list of values and adding them together. We shorten it using the Greek sign that looks like an E, right? And then remember the two formulas for an arithmetic series and for a geometric series. There's also a quadratic series, but a quadratic series, it will normally be when the number of terms is normally not even more than 15 or not more than 10, because you need to add them manually. You don't have a formula for a sum of a quadratic pattern, so you will just add them as individual digits and get the answer there. Guys, for now, let's just walk around the house a bit so that we can get some fresh air and get some blood flowing in our mind and our body. But for now, let's quickly take an ad break and I'll be back with some more maths. Hi guys, welcome back to the last segment of our show today. Guys, I hope you've been having so much fun. So far, we've looked at a sequence, right, which is in two ways. It's either an arithmetic or a geometric, right? There is also the quadratic sequence, which we really did not look at because I know that one you are very clear with. And then we also went on to look at a series, which is also either a arithmetic or a geometric. Now, with the geometric series, we then have when it is a converging series and a diverging series. What does that mean? Remember, converging, it is more like coming together, right? And diverging is more like going out. But mathematically, when you say something is converging, we are saying that it is becoming smaller and smaller and smaller. Diverging means it is becoming bigger and bigger and bigger, right? So that's what we're just going to look at. And then we're going to look at what are the principles that make it to be converging and what is the principle that makes it to be diverging. But for now, let's just quickly look at what exactly do I mean. Because I know at times I say all of these things and you're wondering, what is this guy saying? But then let me show you what I'm talking about. Now, we have what we call a converging and diverging series, right? A geometric series, one, will converge. What does that mean? The sum will approach a specific value, right? So the n will approach a certain value, which I can just say, let me not use a, because then I will confuse you. Remember, a we said is the first term. So it approaches a value k, which is a specific value that we do know. So there is a limit, right? If the value of r is trapped between minus 1 and 1. So the value of r should be greater than -1 and should be less than 1. So if it's maybe 1/2, then it's okay. If it's like 0, then also it is okay, right? And then a geometric series will then not converge. The not converge will therefore mean what? It is diverging, right? Because converge and diverge are like synonyms of one another. This means that the sum will become very, very, very large, right? The sum will be very large. And what this means is it is a very big number that you are going to get. It is approaching infinity, right? And then if r does not lie between the -1 and 1, so if my r is like 2, then that series is actually diverging. If my r is like -3, that series is also diverging. When a series is converging, we can then find the sum to infinity. Why sum to infinity? Because it is approaching a specific value, right? So if r is greater than -1 and less than 1, then we say this is a converging geometric series. Then I can use the formula sum to infinity is equal to a over 1 minus r. So one thing that I want you to please note here is when I say infinity, I'm talking about a number of terms that is infinite. I do not know how many terms are there, like 2, 4, 8, and then 16, 32, with an ellipsis at the end, meaning that it is continuing indefinitely. I don't know what is the last term or where must I cut the number of terms. Then I will use this formula. But the question will specifically say to you, calculate the sum to infinity. So you don't need to then have to memorize certain things that will then tell you whether it's infinity or not. They will tell you specifically on the question. Let's look at some questions with this. So firstly, you need to consider the sequence, right? I have 2, 1, 1/2, and 1/4. Firstly, determine the common ratio. Why am I saying determine the common ratio? The common ratio is going to tell you whether you will be able to find the sum to infinity or not. If the common ratio is not between 1 and -1, then clearly I cannot find the sum to infinity. But if it is, then I can find the sum to infinity. So let's see what I'm talking about, right? So the common ratio, remember, will be 1/2. So r will be equals to 1/2, which is the 1 divided by the 2 there. Let me just label them T1, T2, T3, so that you don't think it's this 1/2. So this is the same as T2 over T1, right? Let's look at maybe the other one. If I say T3 divided by T2 will give me the same thing. That's 1/2 divided by 1, which is also what? 1/2. So you can see that it's actually the same value. So my r is actually just 1/2. I was just trying to show you that even with T3 and T2, it will still be the same value. Now, let's go back. What did we say? Only if the r value is between -1 and 1 can I then use the formula. So is it? Because I got 1/2. It does lie between the -1 and 1. Therefore, I can find the second question that I have here. So to find the sum to infinity, it will therefore be equal to a over 1 minus r. Remember, the a value is the 2, the r value is 1/2. Then I press my calculator. Firstly substitute, then go to your calculator. 2/1 minus 1/2. But really here, I don't think you even need your calculator, but let me do it with mental maths, right? So this will be 2/1 minus 1/2 is 1/2. So how many halves are in 2? You know that there's going to be 4 of them. So that will be my answer. So you can see that it is approaching a specific value that we have there, and that's how you will then solve that. Also, this can be given in the form of a sigma notation, right? So remember the formula of the sum to the geometric sequence, which is Tn is equal to AR to the n minus 1, right? We can try and link this back to that so that it becomes easier. But you don't necessarily need to do that. Remember my steps that I gave you, that we spoke about, expand it. So it becomes 2 into 1 over 3 to the exponent of 3. Why 3? Because the first position is at 3. Plus 2 into 1 over 3 to the exponent of 4. Plus 2 multiplied by, so not 2 over, 2 into 1 over 3 to the exponent of 5. So just get 3 terms. You don't need to get all of them, right? So automatically, guys, you can already see that the 2 and the 2 will divide when you're trying to find what the R is, and then the 4 will minus that. So it means my R will actually just be 1 over 3. Does this qualify me to use the formula for sum to infinity? Yes. Why? Because it is between minus 1 and 1. And then my A value will be the value that I have here, which is 2 into 1 over 27. Remember, 3 cubed is the same as 27. And then I will go straight to my formula then. Let me remove that formula up there. Remember, that was just for me to try and show you where this comes from. Now, to then find the sum to infinity of this, I will say sum to infinity is equals to A over 1 minus R, excuse me, which is equals to the A value we just said is 2 into 1 over 27, all divided by 1 minus 1 over 3. So here you don't need to go mental math on this. You can just go straight to your calculator. So let me show you. So this, firstly the fraction, 2, open the bracket, another fraction, 1 over 27, and you close your bracket there, divided by 1 minus another fraction, 1 over 3. Then you get your answer, right? Which will then give you 1 over 9. Okay, so this will actually be equals to 1 over 9. And that will be my final answer there. Now, just to summarize everything that we've done, guys, is make sure that you write out the terms of a series when given the series in sigma notation. I did give you those notes for you to please look at. Also, the sigma notation of a series when given the terms as a sum. So it was the 2 steps that I gave you in terms of 3s, right? I gave you 3 steps and 3 steps for 2 parts of this. It's when you are given the sigma notation, they want you to find the sum, or you are given the terms and they want you to write it in sigma notation. Just also, an arithmetic series is formed when adding the terms of a sequence where the terms differ by a constant, right? The constant difference that we spoke about. And then a geometric series also is when then the sequence, the terms are differing with what we call the common ratio. Remember, between the consecutive terms, guys. Not just any terms. You can't take T1 and T100. No, it must be T1 and T2 or T2 and T3. Like that, they must just be consecutive to one another. Our roadmap of what we've looked at so far, it was a sequence. And then we said a sequence, there is 2 of them, the arithmetic, and then the other one is the geometric. With the series, there is also arithmetic and geometric. And geometric and arithmetic, both of them can be written as sigma notation. And then with the geometric, it is either converging or diverging. If it is converging, then you can find the sum to infinity of that. So guys, really this normally, number patterns, I know that it is normally like 2 or 3 questions in the question paper when you're writing your exam. I promise you, if you just master this, it means you've already answered 2 or 3 questions and you got them right. Maybe there will be just that one question that gives you a problem, but already you would have scored some marks. and also look at your algebra, and then you can then strategize after that. But from me, guys, remember, mathematics is food for the soul, and everything that we've done here, only if you take it up and practice it, I promise you, it will nourish every fiber in you. From me, the Maths Doctor, until I see you next time.